Thank you.
When we listen to Facebook and Google, we are excited. So Dr. Lily is from Google, welcome, and Dr. Yann is from Facebook. Let's start with you directly, Dr. Yann. Tell us how it all started and when. What is deep learning and why Google and Facebook are working on?
Right, so the reason we hear so much about AI today is because of deep learning. It's a technique that has become very popular over the last 5 years, roughly. But the origin of it goes back to the late 80s. So back in the mid-80s, late 80s, people were working on artificial neural nets and came up with techniques, one of which is called convolutional nets, which is a little bit my invention. And these techniques were used a little bit in the early 90s, and then they went dormant because the machine learning and AI community lost interest in those methods, partly because they were very difficult to, it was very difficult to make them work. The software at the time was not as flexible as it is now. The computers were not as powerful as they are now, and the data sets that we had to train them were not as big as the ones we have now. So people lost interest in those techniques for quite a long time. And in the early 2000s, myself and a few of my colleagues, namely Jay Finton, who was at the time University of Toronto, is also at Google now, as well as Yoshua Bengio and a few others, tried to restart the interest of the community in those methods, artificial neural nets, convolutional nets, and what we now call deep learning. And for a number of years, it was very difficult. Nobody was interested. And everything changed around 2010, 2012, when those techniques started to work really, really well for speech recognition and for computer vision, recognizing images with computers. That occurred in 2012-13. And that created a huge wave of interest. A lot of people stopped whatever they were doing and started using those techniques because they saw the opportunity. And that's also just about the time when companies like Google, Facebook, Baidu, Microsoft, and a bunch of others started investing in those techniques and creating groups that were specifically focused on deep learning, essentially. That's why we hear about AI now. AI was a bad word for many years. I didn't claim I was working on AI. Now that it's starting to work, it's become fashionable again.
Dr. Lily, how much did the development of technology help medicine to reach this stage, especially that you're working in the medical field?
Yeah, absolutely. So, the concept of having a computer assist in image interpretation has been around for a while. In fact, in the 1998 was the first time some software was approved for helping look at mammograms. Unfortunately, some of these systems were actually quite brittle. They were rules-based, some of the sort of non-neural net techniques, and they weren't really good at modeling very complex systems, like biological image. And so what has been pretty remarkable about deep learning is that the algorithms that are trained are actually really robust to noise and very accurate. So you can handle images that have poor quality, can handle a variety of types. And so that's been really, in medicine, accuracy really matters, right? So the difference between a little bit of performance can make a big difference between a product that is actually useful and a product that is not useful, right? So 70% accuracy in some cases is just not good enough, and you need like 90, 95. Sometimes 95 isn't enough either. So that accuracy part is really important. And so that's been, that type of fidelity has been what's, I think, captured a lot of interest in the medical community. Yeah.
And what about the last project? The last project you're working on?
Yeah. So I personally work on applying some of these amazing techniques that Yann invented to medical images. And some of the very interesting use cases is for screening, because there's a lot of data that comes out of screening. And, quite frankly, there's just not enough doctors in the world to look over all this health care information that we have. And so our project was in screening for diabetic eye disease. So everybody with diabetes is at risk for blindness caused by the disease.
Dr. Lily, screening the eye,
yes,
right?
Yes, so you have to take a picture of the back of the eye, and then we have to grade it and look for little lesions. And so we actually then trained an algorithm to help with that task. And so that the algorithm was actually, quite robust, and it was very accurate. And so that's one of the reasons I think people were very excited about this, and including physicians, because it now becomes a very clinically relevant tool. So that's kind of the origin of how we started using this technology in medicine.
Good to know about that. Dr. Yann, how successfully has this technology spread all over the world? And we should know if we can find this technology today everywhere.
So deep learning is used almost everywhere, sometimes in applications that you see every day. So if you take your phone and you talk to your phone and your voice is being recognized, it's a deep learning system that recognizes your voice. If you connect on Facebook and one of your friends speaks a language that you don't understand, the post will be automatically translated to a language you understand. That's a deep learning system that does the translation. You upload a picture on Facebook, and some of your friends are in the picture, they're going to be tagged automatically. Not if you live in Europe or Canada, but everywhere else in the world, yes. And so there is a number of things like this that people can see that are sort of directly visible. The applications that we're going to see are things like applications to medicine that Lily talked about. Of course, a lot of people are excited about self-driving cars, and most self-driving car systems now use deep learning. So some of the cars that you can buy now that can, basically stay in lane in a highway and do things like that, they have, a camera looking out the window, and behind this is a convolutional network. The same technique that are used for image recognition and for speech recognition, essentially, it's the same methods, just trained on the different set of data. So the way we train those machines, it kind of sounds strange that you train a computer, right? But normally you just write a program and the program just executes the instructions and that's it. But what we can do with deep learning is that there's another name for it called differentiable programming. It sounds complicated, but what it means really is that you don't give a precise set of instructions to the machine. You tell it, you're going to do like a sequence of instructions, but I'm not going to tell you exactly what it is. But what I'm going to tell you is, here is an image of a car, and you should turn on this light if I show you this image. And if I show you the image of an airplane, you should turn on this other light. If I show you the image of a tumor, turn on that light, that red light. And so you collect thousands of images of each of the things that you want to classify. And every time you show the image, if the system produces the right answer, you don't do anything. If it gets it wrong, you tell it, here is the correct answer, modify yourself. So you get the right answer the next time. And it's, at a very high conceptual level, a little bit similar to what, how the brain learns. It's not really quite the same, but it's inspired by it, certainly. And so we're going to see this spread across a lot of different applications. And we learn about new applications of this every day. There's people who have ideas in, environmental protection and, financial industry, energy production. There's all kinds of applications of this that, I never thought about when I was working on this a while back. It's going to take a while before it disseminates everywhere, but I think we're going to see this everywhere. So today, there's a lot going on behind the scene when you connect to Facebook or Google, where those techniques are used to basically determine what to show you. So you go to Facebook, Facebook can show you maybe 2,000 or 3,000 pieces of information per day, but nobody has time for this. So Facebook has to select about 100 or 150 to show you every day, and that has to be the most interesting content for you. So the automated machine learning system at Facebook understand the content, and they also know about your taste, and they kind of match the two. And there's similar things at Google for search results and for filtering objectionable content, for all kinds of stuff like that. Classifying hate speech, everything.
We will pay later on in Facebook for those technologies. Till now we are going, searching, doing whatever we want for free. But later on, do you think those technologies will pay for them?
No, in fact, is an interesting phenomenon that occurred, which is that both Google and Facebook are, of course, deploying those technologies very widely, but are interested in solving much more complex problems. So one thing we don't have today is a virtual assistant that you can talk to and is not frustrating to talk to, right? Most of the existing one, not Clippy, that's an extreme case, but let's say Siri, Cortana, Google Home, all that stuff. You can talk to them, they're scripted, so there is a certain number of topics that they can answer, a certain number of requests that they can do. They can give you the weather, play music, and tell you about the traffic, but that's about it. And we'd like them to have common sense. We'd like them to be real virtual assistant to understand everything we tell them. And we don't have the technology today. And so it's a big quest that everybody in AI is trying to do, is build intelligent machines that have common sense, that have enough intelligence so they're not frustrating to talk to, and they can assist us in our daily lives. And that it may take 10 years, 20 years, 30 years. We don't quite know how long it's going to take.
I'll come back to you, Dr. Yann, to ask you if we are safe when we are on Facebook.
Yes.
I will come back to this question. But here, let me move a little bit to medicine again and ask Dr. Lily. We just spoke about advantages of this technology. Let me ask you about side effects. We're worried when we are speaking of technologies in medicine, especially in medicine.
Yeah. So one of the, like I said, one of the great things that Yann actually pointed out right there was the ability for these models or these networks to learn from examples. So you don't actually have to write these explicit rules. Now that becomes more problematic if the device malfunctions. Then how do you go back and fix something, right? And there is some criticism around how these neural nets do not kind of explain themselves. It doesn't lend itself to good explanation about how decisions are made in the system. And that is one kind of, there's a lot of research here called attention techniques and saliency mapping that, at least in an image, while the network is making a prediction, it also visualizes the pixels it uses to make that prediction. So this is a place where there's a little bit of a shortcoming, but the machine learning community is really rising to the challenge and trying to, kind of fill that gap. And then, of course, the next thing we talk about is generalizability. So these networks can be very accurate, but they can overfit a system, which means that it customizes itself to a system so much, it doesn't apply very well to another population. And that's not atypical for a lot of different kinds of machine learning. It's just more prone in deep learning because it's kind of so powerful. And so what we do in medicine is we do validation in this other. So one, we make sure the data set is big enough and representative of the population that we want to deploy this software in. And then there's a lot of validation that we do, both prospectively and retrospectively, to make sure, so you always kind of check on multiple data sets to make sure that the algorithm is performing the way that you want to. And you would never actually use a software that's not validated in that.
We will see this technology replacing the doctors in the future.
Well, I don't think about replacing as much as changing the way that we do our work. So, yeah, so the reality is there's so much medical data, and most specialists go through, I would say, over a couple of decades of training. So 15 to 20 years of additional training. And our job is then to try to understand this data. And even then we're pretty overwhelmed and we make mistakes. And so now what we have, and human beings have already done this. We try to hire assistants to help us pre-screen things. We try to have junior doctors read things first. And now you actually now have a sort of a soft piece of software that can kind of help you, and the piece of software never gets tired, it never gets jet lagged, and so it's actually a really great assistant, and it changes, it unloads you in terms of this cognitive burden for detecting, reading images, where you can actually focus a lot on talking to the patient and counseling the patient.
Dr. Yann, why deep learning is so remarkable and different today? And beyond medicine, Who else is using this technology or the deep learning?
So certainly an increasingly large number of industries and people for all kinds of applications in the non-commercial sector. I mean, there's all kinds of applications. And what makes it different from previous methods is the fact that previously, if you wanted to use a machine learning system, you had to do a lot of work. Experts had to do a lot of work to kind of transform the data into an appropriate way for this machine learning algorithm to work. So if you wanted to build a system, for example, that figures out what a piece of text talks about, like one of a number of topics, or if you wanted to build an image recognition system, most of it had to be engineered, and then there was a little bit of learning on top. And what deep learning has allowed us to do is to basically feed the machine with the raw data. So the pixels of the image, the raw text in a very simple form, and without having to the expert process of transforming the data first. And what that means is that now there's a lot of people who are not expert who can use very standard software and apply them to a lot of different applications without necessarily themselves being machine learning experts. And so there's pieces of software that are put out by both of our companies, TensorFlow for Google, PyTorch for Facebook, and there's a number of others that I'm sure a lot of people in this room have used some of them. Can you raise your hand if you've used either PyTorch or TensorFlow? Okay, here you go, a bunch of people. And you have high school kids, in their parents' basement using the GPU card that they normally use for gaming, running deep learning software, and it's very easy to get something going. And you want a system that takes pictures in your backyard and recognizes which animal walks by or something, whatever. So it leads to a lot of creativity because now it connects. There's a lot of people who have ideas for applications who now are in a position to actually try it. Whereas in the past, they would have to knock the door at the university and say, like, can you help me with this problem? And say, I don't have time to help you. So that is democratizing AI, and it's expanding the number of applications. And it's probably going to take 10, 15 years before all the applications of the technology that we currently have is disseminated across the entire economy. But and when that happens, we'll see probably economists tell us that we'll see an increase in productivity and things like this. But democratizing those techniques for non-experts is really what's key there.
Let's talk with you, Dr. Lily, about the difficulties you faced during your journey.
Yeah, so the interesting thing is because of PyTorch and TensorFlow and all these other things, the machine learning portion of the work is actually more straightforward than the thing that comes before it, which is getting the right data set and getting a clean data set, especially in medicine. And so, especially since it requires such expert skill to read them right. And so what we actually had to do was hire, for this particular project that I talked about, we hired 54 ophthalmologists and had them label 130,000 images, and they rendered about 880,000 diagnoses. So it's a lot. It's a lot of, kind of labeling. Now, once you get those labels, the machine learning can proceed and can proceed actually rather quickly. But getting that right data set and getting that labeled in a clean way has been probably challenging and will probably continue to be challenging.
Dr. Lily, what is the difference between being at Doximity and now being at Google?
Well, Doximity was a startup, so it was a smaller kind of team. This is a much bigger team at Google. The research group is actually quite big. A small startup can't support a large research group, and there are already a lot of established products at Google, and a lot of people who've had experience deploying new technologies into products to make them better. And so the folks there that have that experience, they've been amazing to work with, and because I come from a medical background, and bringing that and coupled with the machine learning background, and then people who really know how to build good software, has been quite, that's been, I think, the secret sauce in building a good team.
That's nice. So let's talk a little bit about artificial intelligence. Do you agree first with this title that artificial intelligence or AI is taking over our lives? And I will ask you later on how. Let's start with you, Dr. Yann.
Well, it depends what you mean by taking over your life. Of course, if you use Google or Facebook a lot, in a sense, AI has already taken over your life because it runs all of those systems. If you're lucky enough to have a high-end car that drives itself on the highway, again, your car is being run, maybe not your life, but your car is being run by AI. So I think increasingly we're going to see those applications. But it doesn't run your life in the sense that we don't have truly intelligent machines that are as intelligent as humans. We have machines that are very narrowly intelligent, right? So we have image recognition systems in medicine or in other applications that can recognize images with better accuracy than most people. For example, it's relatively straightforward to train one of those convolutional nets to recognize species of insects or plants by just looking at the shape of the leaves. And most people can do this, right? Face recognition systems have superhuman performance also. But all of those systems are very specialized. It's very likely that within a decade or two, your self-driving car will drive your car better than you can drive it. And in fact, I don't think self-driving cars will be deployed until their reliability is probably about 10 times better than human drivers, because people will not accept them unless they improve the safety. Those are narrow intelligence, very specialized intelligence. And we don't have the technology, we don't have the science, we don't have even the basic principles to build machines that are generally intelligent as humans. But let's not even talk about humans. We don't have machines that have as much common sense as a house cat. Okay, so I would consider it a major success of my career is by the time I retire, we have intelligent machines that are as smart as a cat.
Oh my God. What about you, Dr. Lily? What do you think about that?
Yeah, so I mean, I agree essentially with Yann, and at least especially in the healthcare space, where we're seeing these technologies, and well, they'll probably deploy a little more slowly in medicine because there's a lot more clinical validation and regulation that goes involved in it, and I think we're training and what a lot of folks are making are better tools for a doctor. So an analogy is rather than feeling your head for whether or not you're hot or cold, we now have a thermometer that can better actually quantify how hot or cold you are. And in the same way, right now we look at images and we go, kind of not, it's sort of abnormal, and we're not really good at quantifying how abnormal. And so in this way, I think we're going to get more precise and better tools. And then, so I don't know. I don't know. So in medicine, I don't think it'll take over that much of their lives. I think in the consumer space, I'm clearly, it's taken over my life. I work for Google and I work here. But what I've noticed is, for example, there'll be the subtle things that actually delight and make you happy. I used to spend a lot of time putting together photos of my kids, altering them so that they look good or trying to make a movie out of them. And now, in the Photos app, it just kind of does it for you. So you can actually focus on how cute and adorable your kids are rather than, manipulating the pixels.